Hello and welcome to today's problem 226 invert binary tree. So you're given the root of a binary tree and you want to invert it and then return its root. So okay, that makes sense. You're given the root as the initial one, as a parameter of the function, and you have like this binary tree, for example. You switch it, so for example we have 2 and 7 here, it'll turn into 7 and 2 over there. And for a smaller tree, 2, 1, 3 equals 2, 3, 1. Okay, so an idea in order to invert the tree, what we could do is, since we're given the roots, and the root is a tree node that's constructed like the following. You're given references to the left and references to the right. What you can do is you can set the left one to equal the right one and vice versa. So in order to after you switch these apart, you want to be able to invert the tree for the children. So you're gonna have to call that method for those ones as well. So if we kind of think about how this is gonna work, you start off with the roots. In this case is 4. You're given the left and the right nodes, which is 2 and 7. You set the left, the 4's left one to equal 7, and you set the right ones to equal 2, and then you call the invert tree method on like this one on 7 and on 2, and eventually it'll happen for its children until it reaches nothing, whereupon it'll turn null. So okay, so that makes sense. The time complexity of this would be O of n, because you're just traversing through every element within the tree. And yeah, okay, that makes sense. Yeah. So just to implement this, we'll start off by having a guard to check whether or not it's null, the current root. If not root, we want to return nothing. Yeah, that makes sense. Next thing we're going to want to do is we're going to want to traverse through every single element. So okay, so with this invert tree, okay, we're going to want to call invert tree on the actual root itself. Okay, actually, wait, let me think about this. Okay. So what we're going to want to do is we're going to want to check to see if I'm going to want to invert the left, and we're going to want to invert the right. So we do root.left equals invert root.right, and we're going to do root.right equals self. So what we're doing here is we're switching these around. So the root, the left is equal to the right and right is equal to the left. And then we're calling this method again with itself. So it'll keep repeating until it reaches the case where there is no root anymore, whereupon it'll return none. After that, you were going to want to return the root. Okay, so just to walk through this again, this logic, we check to see, we're given the root, we're given 4. We want to check to see whether or not it exists. It does. And it wants to set the left to equal the right and the right to equal the left. Oh, also a problem with this is that if you set the left equal to the right, then this will effectively just be setting it back itself to again, since the left is equal to the right. In order to have this work, we need to have a temporary variable. So temp, which is equal to root.right. And then we can call self.invert tree on the temporary, so it doesn't have to loop in kind of back on itself again. Gotta watch out for that one. So if we go ahead and run this now, some initial test cases. Okay, let's see what's going on here. Okay, so root.left, you want to invert the tree again with the rights, and whoops. We want to set this equal to root.left originally, actually. We run this again. Okay. Yeah, sorry, I just mistyped. So yeah, so we're setting this temporary to equal to left, and then we're passing that in here in order to make sure that when you do change the left to something else, then the original value will still be retained in the temporary variable, which you can then pass in for root.right. If we go ahead and submit this, yeah, we're accepted, and yeah, that's it. Thank you for watching.